Thanks everyone for listening in, joining our presentation. Today we have Neil Strother and myself, Michael Kelly, discussing AI across the industry. I'm a senior research analyst with Guidehouse Insights. I might be better known as Navigant Research, formerly. Who are we? We're a premier market intelligence and advisory firm. We provide emerging technology research and benchmarking across a number of clean technology verticals. So everything from smart cities, electric utilities, smart buildings, smart transportation, and kind of everything in between. So what do? We guide clients through uncertainty and risks towards market opportunities. Again, my background is in utility software platforms. So that covers kind of your core enterprise software, data analytics, and then cybersecurity solutions, in addition to running some of our AMI research. So in terms of setting the stage, again, what we're going to try to accomplish here is cover AI-based utility analytics applications from both the customer and grid's perspectives. Obviously AI has received considerable attention across the utility industry, and rightfully so. It's largely been looked at as a forward-looking capability over the last 5 to 10 years. But what we're actually seeing now is AI and machine learning deployed across the utility industry from the customer operations perspective, customer engagement, and then obviously across grid optimization. So this presentation will cover some of the advancements in AI and ML across these applications, highlighting some of our forward-looking projections and identifying some key recommendations for utilities and vendors alike. As with other industry buzzwords, DERMS certainly comes to mind. People can play fast and loose with the term AI, machine learning, and some of those subcategories. And in terms of Guidehouse Insights, how we look to define AI is the implementation of advanced computer science techniques that emulate human-like capabilities to solve problems, create greater efficiencies, and deliver positive business outcomes. So, what does that actually mean? Breaking that down a little bit more, we view AI as kind of having subclasses or branches and iterations that make up this larger AI tree. So everything from machine learning to natural language processing, artificial vision, voice analytics, a number of branches that ultimately make up this AI. And those different subcategories are going to play differently across smart homes, T&D networks, smart cities, right? So it's this combination of these subclasses that permeate the utility industry and deliver what we call AI. And another way of thinking about it is the idea of, in the context of analytics, I view AI as sitting on an analytics continuum rather than replacing everything that goes before it, right? So it's a natural kind of evolution as we advance these AI capabilities. So we're going to jump into some of the grid-based applications, some of the ones that I see as kind of the most high value today and really playing a role in the grid of the future looking forward 5 to 10 years. And what we have is a schematic demonstrating the complexity of the utility analytics value chain. So on the left side of that chart, we have our data generation, right? So that could be from raw data sources, increasingly being seen in downstream networks, transmission and distribution networks that largely weren't instrumented with network devices 10, 15 years ago. We see increasing penetration across substations, feeders, transformers, and then ultimately at the actual meter. You also have internal systems, whether it be an ADMS or an MDMS, feeding data via integration to some of these analytics platforms. We have the whole data management functional area where you deal with stuff like data ingestion, verification and estimation, data storage, which has certainly been an area in which utilities have placed kind of focused investment around data lakes, data warehouses, emerging data platforms. Then you have things like data security, API management, and then finally the analytics applications themselves, again, cutting across customer operations, engagement, and grid operations. Really, the point here is that we see AI and machine learning permeating each of these functional areas with increasing frequency across global utilities. Now what we have here is the kind of diverse and complex vendor landscape. So again, we have kind of 4 areas in which we traditionally classify these vendors. We have the large OT providers up at the top here, the GE, Siemens, Schneiders, ABBs of the world, typically embedding some of these analytics capabilities into their ADMS or DERMS platforms. Then you have your enterprise analytics providers, the SaaS, IBMs, or C3s of the world, focusing on analytics across a number of different verticals. You have your end-to-end AMI providers, Landis+Gyr and Itron, typically embedding analytics as a function of their MDM or as a function of their smart meter deployments, usually as a value-added analytics application. And then finally, we have the Bidgely's of the world, right? So these analytics providers that are hyper-focused on the utility business and generating insights specifically for that utility vertical. So in terms of some of the key applications that I see, again, kind of resonating today and more importantly, kind of playing a large impact 5 to 10 years down the road. If we start at the bottom of the schematic, we have load forecasting, one of the most commonly deployed use cases today. Traditionally a function of smart meter deployments. Again, it can be offered as part of an MDM module or as a standalone load forecasting analytics package. And that's where we're seeing some strong innovation across the micro forecasting application. So as you can see here, we expect a high impact in terms of load forecasting over the next decade as new markets look to deploy smart meters and as mature markets move towards these more micro forecasting granular technologies. Network modeling is the next level up here. So when we talk about network modeling, what I'm really kind of referring to is the idea of connectivity models. So knowing where your assets are on the grid, how they're interconnected with one another. And this has been something that utilities have struggled with for some time. Simply knowing what meter is connected to what transformer or what phase identification there is on that particular house. This is something that utilities have struggled with. And we see standalone analytics packages and some smart meter deployments trying to improve these connectivity models as a function of some of these enterprise software strategies. Moving up to more forward-looking applications, we have asset performance management. This has been an area in which I've been fielding a disproportionate share of recent inquiries. And so that covers everything from asset health monitoring to asset risk and investment planning, predictive maintenance of failure of assets. So what we see today is a lot of coverage at the generation and transmission level, some interest, but again, more forward-looking is penetrating the distribution level and covering some of those line sensors, distribution transformers, and ultimately at the meter. And finally, we have DER integration. So again, some of the applications that we see utilities interested in and vendors kind of promoting solutions around are the ideas of modeling, forecasting, and detection of DERs. All critical functionalities of DERMS and DER analytics offerings that we see today. And then the other graph here, we have those 4 different categories and areas where we see particular opportunity for those functional areas. So again, in terms of load forecasting, typically driven by smart meter penetration, but you also have analytics companies like Bidgely who are supporting non-telemetered assets for some of those load forecasting techniques. So some innovation happening across that use case. Network modeling, again, EV and PV penetration, these dynamic loads and increased assets introduce more complexity to these connectivity models. And the idea of asset performance, again, G&T utilities, that's where we see a lot of the traction, at least today, is among generation and transmission assets. Looking forward, there is expected to be increasing penetration of APM across distribution assets. And then DER integration, again, we've seen interest across obviously Germany, Hawaii, California, Australia, areas where you have high EV and PV adoption. We're seeing increased traction for some of these DER integration tools. In terms of the market outlook, strong growth projected across some of these AI-based analytics solutions. According to Guidehouse Insights, one of our recent reports estimated growth over the next decade to increase from 1.4 billion to 4.4 billion, CAGR of 14.1%. And again, coming from a utility software background, if you look at the growth rates of some of these core platforms and even some of these high growth analytics segments, that 14.1% is disproportionately high when looking at some of the other more static or rudimentary software platforms. And there's a number of reasons for that strong growth forecast. In terms of some of the drivers, you have the proliferation of network devices leading to that data overload, right? If you don't do anything with that data, it's essentially a sunk investment. So that's driving a lot of investment in some of these tools that can actually make use of that data. We covered DER integration. Again, that's forcing utilities to optimize some of their operational activities to facilitate that DER integration. We see advancements in some of the analytics capabilities and techniques in terms of the algorithms. And then cost pressures, utilities obviously under constant pressure to continue reducing costs, increase their operational efficiencies. And we see AI-based tools coming in and achieving some of that. In terms of some of the barriers, poor data sets, we'll get into that a little bit and a bit here in terms of connectivity models and what tools we're seeing deployed to help fix those. Skill shortage, obviously, something that's, kind of omnipresent in the utility industry. When we talk about some of the IT and skills needed to deploy some of these advanced analytics platforms, there tends to be a gap across some regions. And then naturally some cost and complexity concerns that are inherent with these larger enterprise software platforms. So I want to dive into some of these applications and some of the more interesting kind of innovative stuff we see happening across those 4 functional areas or 4 analytics applications. So when we talk about load forecasting, again, this is one of the most commonly deployed analytics use cases we've seen, typically a function of smart meter deployments. But what we've seen in the last 2 to 3 years is a lot of innovation around these load forecasting, where instead of using the more rudimentary top-down analyses based on historical data, we're seeing dynamic bottom-up modeling techniques with a real focus on dynamic profiles and DER integration. So, some of the key trends I've seen, obviously input parameters have been growing to now cover things like cloud cover, wind forecasts, EV penetration, again, more dynamic load forecasting techniques. A lot of use cases going from simple load forecasting to dynamic applications around revenue, asset management, locational pricing. Again, I mentioned Bidgely, but developing advanced algorithms for output of non-telemetry DERs that could be particularly important in emerging markets where smart meters are still not, haven't become the norm quite yet and may not, for the next 10 to 15 years. And really what we were seeing is a gradual shift away from those traditional geospatial or econometric models and towards more advanced scenario and simulation engines, again, to support these more dynamic load profiles with DER integration in mind. So, naturally feeding into, DER integration, we've seen DER penetration already causing some disruptive grid impacts. Again, I mentioned Germany, California, Hawaii. So in terms of, what are utilities doing to try and mitigate some of these concerns, modeling, forecasting, those are all great, capabilities that are typically first deployed under a DERMS. Well, if you don't know where your DERMS are or DERs are, then the modeling and forecasting really becomes moot. So what we've seen across some of these standalone analytics companies and a couple of the OT providers is creating solutions that can actually help you detect where EVs are and where PVs are in your network. So PV and EV ownership often grows in pockets. You have these neighborhood effects. So these effects can typically be highly localized. So understanding where the EVs are, size of the chargers, with PV, understanding the contract type, the positioning of the PV, you can really create some more efficiencies in terms of your load forecasting engines and your DER forecasting engines. So again, there's a lot of feedback loops in terms of downstream benefits. Back to the idea of connectivity models. Again, this is something that has plagued the utility industry since they went from pen and paper to digital asset mapping. The idea of a connectivity model is essentially, just knowing essentially where your assets are, how they're connected, how they communicate with one another. But if you look at even, a lot of utilities across North America and Europe, there are still 10 to 15% error rates on simply knowing where your meter is connected to your transformer. So again, naturally, there's a lot of kind of low-hanging fruit and lost operational efficiencies in terms of your ADMS, your GIS, and simple grid topology, not knowing where things are. So how can AI and machine learning come in here? From everything from data integration, data discovery, feature extraction. We've seen a number of utilities across North America and across the globe apply some of these AI and machine learning techniques to help improve their connectivity models. So this is taking data from your GIS, from your smart meters, from your SCADA, from your DMS. Some of the more innovative applications are leveraging and integrating those various disparate sources of data to help improve those basic kind of grid topology connectivity models. And the last one we want to cover here, again, we touched on a little bit briefly, was asset performance management. An area in which I've seen a lot of interest from utilities and vendors alike. Again, it's traditionally been a conversation at the generation level, just given the cost and criticality of those assets. But as the APM technologies have advanced, in line with your asset management systems, we're seeing increased interest down at the distribution level. Enel in Italy has deployed distribution level APM across some of their assets. And really what ultimately we can do at the distribution level, which I think is particularly interesting, is aggregating smart meter data and then aggregating that up to the transformer or system level to enable higher levels of situational awareness. Right? It might not always be cost effective to deploy a sensor or a monitor on your transformer or on the low voltage side of that transformer. But if we have analytics techniques that can aggregate some of those smart meter level information, aggregate that up to generate system level insights, that's where we can really make an impact. So with that, we'll slide into the customer-based applications, and I'll let Neil Strother take it from here.
Thanks a lot, Mike. This is Neil Strother. As he mentioned at the top, I've been an analyst for a number of years. My title now is Associate Director. And some of the areas I cover include home energy management, the smart home, smart buildings, the Internet of Things, and again, the smart grid. So a lot of kind of overlap with what Mike's talking about. But now I want to talk about kind of home energy management and some of the market drivers there. And what we've seen over the years is that it's really kind of been changing from energy management really to greater engagement with customers. There are things happening behind the meter, including smarter thermostats, smart plugs, again, kind of behind the meter drivers that put the customer more engaging with energy. And I think that's a big home energy management market driver. We're also seeing adoption of smart meters, which Mike alluded to, and we see that as growing and a force giving more data into the system for the utility, and also helping out with energy management on the customer side. There's also some new standard coming through the DOE. It's called the Smart Home Energy Management System Standard. It's not here yet. It's being developed, likely to come out in the next year or so. Again, I think that'll be a driver for vendors in the space and for customers on the behind the meter side, to get a set of standards that they can match to their needs. We also see that there are environmental concerns that people have. They want to be really efficient with their energy, and so energy management becomes an important factor for them. And so any tools that they can adopt are important for them. And then also I think there's this kind of changing customer expectation where we call it the Amazon effect, where consumers expect all the companies they deal with on a digital basis to have knowledge about what they're about, specifically what their needs are, and kind of anticipate what they want to do next. Okay, now I'd like to shift gears to the market inhibitors. One of the things really holding people back is the standardization or lack thereof with the devices that they're purchasing in their homes. They might buy a smart thermostat, they might buy some smart plugs, but again, connecting some of these devices in the home that could provide the kind of data they need just are in silos. And so that's an issue. Another problem is that just utilities are slow to adopt, I think, some of the newer technologies and try to integrate those with their customers. Another key aspect is just the cost. Some of these newer technologies on the customer side aren't all that inexpensive. They can, be a few $100s or more, and that kind of holds people back. And I think there's certain lack of understanding of what's my payoff as a customer, as a residential customer. How much is this going to really move the needle if I invest in these technologies? And I think that's a problem. Beyond those standard market inhibitors, there's a problem with the growing volumes of data that we're seeing. Some homes can tick off tens to hundreds of gigabytes of data per month. And so sorting out that data, how does that happen? It's a real challenge for utilities. I think one of those areas that companies like Bidgely and others, where they can take that data and really dissect it and analyze it and provide information back to the customer, is really important. And it's a problem that can be solved through these AI techniques. Okay, next I'd like to talk about the home energy management paradigm that has been shifting over the last few years. The traditional home energy management report, if you will, or HERS, has been around for about 10 years. And I think there's been a certain amount of customer and utility fatigue around that. And the paradigm is really kind of shifting. What we're seeing is that through techniques like AI and other certain software techniques, those reports and that information can be much more highly directed to the individual and not to a set of homes in a neighborhood. So again, I think through AI, artificial intelligence, these techniques that Mike talked about and that I'm familiar with, you really can dive deep into a customer's actual usage, tease out information that's important that can really change their consumption of energy. And I think it's that tool, that capability that's really going to personalize and make this much more solid. Okay, now I want to shift gears just briefly to the market sizing for home energy management. We see a very robust market over the coming years. For overall global expenditures, we'll see about $4.4 billion last year, growing to about $12 billion in 2028 at a compound growth rate of about 12.3%. You'll notice that hardware is the biggest section of that or segment there at about $3.3 billion, again, growing at roughly the same rate, a little over 12%. So again, I think we can agree that this is a fairly strong market and utilities should have a play here. I want to dive back into kind of the ability of AI and these techniques to offer greater personalization. I think one of the things that's that again is lacking in terms of energy management with customers is that some of the recommendations that we've seen over the years are targeted kind of broadly, or they might not fit. But with AI, you can actually pull in data, not only from meter data, but from weather data, historical data, and as those silos of information that are broken down from the utility side can really hone in on a personal message to a customer. So instead of just a traditional home energy report, a customer could get a text message saying, hey, your usage this past week was really high. Have you checked your air conditioning, for example? Or maybe in a heating season, maybe your heat system is being overused. And or maybe you're on vacation, you get a message that's timely that says, hey, something's wrong. And you could then take some kind of action, maybe alerting the neighbor to check on a piece of equipment, that sort of thing. So again, very personalized, very specific information around energy management, I think is really crucial. And it can also be very helpful to a customer who maybe shifts over from not having an EV to an EV that can be detected by the utility and then offer some real insight into how that's going to affect their bill and those kinds of things. So again, having that very hyper-personalized viewpoint from the AI techniques is very valuable to end customers. One other aspect, I think, of energy management that helps utility through AI is really breaking down those silos that we see. So when information can cross, between maybe an engagement team, maybe the operational team, again, that IT/OT convergence, if you will. With AI, some of those information silos, whether it's from the meter data management system, a team that's looking at customer engagement, maybe a marketplace team, AI can help bridge those gaps and provide operational efficiency so that the customer in the end gets really good insights from the utility. And I think that's an area where operations really benefit from AI, and then ultimately the end customer. In that same vein, I think the call center is a really good example or case study, if you will, of where AI really makes a difference. So with AI techniques, when a customer calls in, the staff person on that call can have a much more comprehensive view of that customer's usage, can also look historically at what they've done, and again, have a complete view rather than being told to wait a minute, I have to check on that, just a much more holistic view. So the customer comes away very satisfied. Also, that staff person, that call center staff person can also make targeted recommendations in terms of marketplace, or maybe the person's called about a high bill. That's obviously the most often reason, but then they can guide them through with information that's useful rather than just this kind of struggle over why do I have a high bill. It can be explained much more clearly. And I think that's a real big win for the utility. It's a big win for the customer. They get actionable information maybe that they hadn't thought about. Maybe there's a connection to a step they're taking. Perhaps they're thinking about a remodel, or it's a seasonal change and they have a high bill. What could they do? Put in insulation. Maybe they're thinking about an EV, that sort of thing. So again, taking those touch points and giving that call center staff person the tools they need, the information they need to be really helpful goes really a long way on both sides for the utility and for the customer. So as we can see, I think AI really has a strong future. It's still early days for many utilities, but as Mike has pointed out, and I think we've seen on the customer engagement side, there's plenty of action in the AI world, and I think it'll benefit both utilities and their customers going forward.
Good morning, everybody. For those who weren't here yesterday, my name is Colin Gibbs. I'm the Vice President of Strategy and Growth at Bidgely. So I'm going to be moderating our Q&A sessions today and for the rest of the week. And again, would just encourage, if you do have questions, to go ahead and drop those in the chat window to the entire audience, and we'll make sure that we field those live. So thank you, Michael. Thank you, Neil. Appreciate the insightful presentations there and all the work that you put in ahead of time, and then being here with us again today. So I have a couple questions in from the audience, and then a couple that kind of occurred to me throughout the presentation as well. So the first, Mike, for you, is you were talking a little bit about the different categories, if you will, of impact that artificial intelligence or machine learning will have over the next sort of near to long term. And it kind of struck me that DER integration wasn't one of your immediate near-term ones as much as load forecasting, for example. And I was just wondering if you could help the audience maybe reconcile that reality with sort of the daily excitement that we hear through various publications about DER integration being the next thing on the horizon.
Certainly. So, I would say that, at least in terms of load forecasting, that's just one that's kind of a natural extension of smart meter deployments. So when you look across North America, Western Europe, in excess of 50% penetration of smart meters, load forecasting is just that kind of initial high value use case that can be realized via an MDM or standalone analytics package. When we talk about DER integration, one thing to mention is that, for kind of low levels of DER penetration, which, we see today, we obviously see high growth potential, but, ADMSs for the most part can handle some of those low levels of DER penetration. But as we look at that forecast 3 to 5 years out, where those DER penetration levels become a little untenable for those more traditional grid management systems, that's where you have these standalone analytics packages around modeling, detection, forecasting, coming in with a higher value proposition. But that's not to say that we aren't seeing already kind of pockets of investment and pockets of grid constraint that are demanding these solutions. It's just more on a fragmented basis. Whereas if you extend our forecast out 3 to 5 years, that's where you see a more global coverage of these types of solutions.
Okay, great. We had a question come in from Jeff. Just regarding, build versus buy and that sort of paradigm for utilities, specifically around, let's just call it like analytics applications, right?
Yep.
And just curious, what you see as the trade-offs from a build versus buy perspective for most utilities.
Sure. I think it's a good question. And I think it's ultimately going to depend on, a couple different things around kind of the business objectives of the utility and the application at hand. So I guess to take a step back, if you're asking, first thing to say is what's the problem you're trying to solve? All right, so is it a mission critical application? Is it more of a low hanging fruit in terms of operational efficiencies that might not be as, I guess, like I said, mission critical or tied into security? So the more kind of upstream and the more kind of mission critical you get, the cybersecurity implications, obviously grow. And that's where you might want to go with a more established vendor than maybe your internal IT team. Also, you got to think about the number of IT integrations. Obviously, this kind of new digital transformation paradigm, we see increasing connectedness of some of these traditionally disparate silos or systems, as Neil mentioned. So as you increase that complexity in terms of systems integration, that might be a potential trade-off versus a more traditional OT vendor that might have a solution set across a number of those disparate disparate systems. You have the data management kind of question. What's the level of data migration and data cleansing? Sometimes your internal staff might, have a better hold on kind of the data. So, again, depending on kind of the size utility, the application at hand, those are, a few of the, I guess, high level kind of considerations that you'd have to do in terms of trade-offs.
Okay.
I was going to add something there too on that. I think it's also time to market. How soon do you need to do something? And if it's really fast, I think a vendor can be the choice there rather than to do it internally. If you've got maybe a longer window, 6 months, maybe 12 months, then it's, you can take a look at doing it internally, build it yourself, depending on your team's skills. But I think that whole kind of time to deploy is a key question there too.
Yeah, great point. We have a question from Norio, which I think both of you might have an opinion on, which is, what have you sort of seen in the way of trends around relatively slow adoption for utilities? And what's the basis for slower adoption of AI applications and a lot of the architecture that you talked about specifically, Mike? Is it just general conservatism? Are there economic reasons? Anything that you have picked up along the way?
Yeah, I'll take a first stab and then let Neil kind of take a stab. But I would say, in general, the utility industry has been traditionally slow moving, relative to maybe some other industries, whether it be kind of the regulations or just kind of the cultural barriers, across utilities. I would say that, for the last 10 to 15 years, it's been kind of slow moving. But then in the past, 5 years or so, as a function of some of these digital transformation and grid optimization, initiatives, I think we have seen, a steep increase in kind of the interest and adoption of these types of solutions. And as you become more instrumented down at the transmission and distribution networks, have more data, which again is a relatively new phenomenon, kind of the business case behind these types of solutions becomes more beneficial.
Yeah, and I would add a couple of just kind of backing up a little bit. The utility business is, its mission is to provide service to everybody. So it's not as fleet of foot, if you will, that a Silicon Valley company could just dive in and just experiment as they go. There's kind of that traditional pressure of, hey, we have to provide service to everybody, and if we change things, can we provide it to everybody, or can we provide it to parts of our customer base? And I think that holds things back to, it's more of a test, and let's see if we can really do it and do it well and not make a mistake and go backwards. So I think that mentality plays into a lot of kind of the advancements. On the other hand, I think AI is one of those areas as well that is fairly new across the board. There's still a lot of learning on the high-tech side, the vendor side as well. So it's not fully baked, and it probably never will be. So again, I think the caution we see is twofold. It's the traditional utility mindset of being just kind of slow and steady, and then that reserve about, well, it's new and we're experimenting with it. We don't want to make too many mistakes, because there's lots of important things on the line, money and customers needing service. So it frustrates me a little bit, because I'd like to see technology move quickly, but again, I'm not a utility, nor do I manage one, so I give them that benefit of the doubt.
Yeah, and I'll just mention one other thing is this kind of concern over data quality that's kind of permeated the utility industry for some time. I think there's been this kind of false equivalence that if you don't have perfect data, then some of these solutions maybe aren't for you. But when I talk to vendors and utilities that might not have top level data quality, but have deployed some of these solutions, is that you can still realize some of these operational efficiencies and get positive business value while also improving your data sets. So you don't need perfect data to explore some of these solutions, and that's held some of the utilities back. But I think it's a paradigm shift in the way that they think about kind of their data. We're seeing more utilities start to deploy these solutions while simultaneously improving their data quality and kind of creating this positive feedback loop.
Yeah, that's helpful. Question directly for you, Neil.
Sure.
You were talking about the applications of AI for hyper-personalization in the context initially about kind of maybe shaking up the HER program model, if you will. So providing more personalized experience for customers. And I'm curious, you provided a call center application example as well on how that might be applied to other areas of the utility and customer relationship. But just curious about your perspective on the opportunity for personalized communications with customers outside the context of energy efficiency programs and just general customer communications, and whether or not you see that gaining momentum as well.
Yeah, I guess I want to understand the question. Do you mean in terms of the channel or the style of message, or?
Yeah, more the value proposition.
Okay.
If we send, for example, text and email and web-based, personalized messages to customers in the context of the HER program, that's great. But are there applications for those same types of communications outside of an energy efficiency program?
Yeah, I'm thinking in terms of when someone is thinking about retail or marketplace, or again, I go back to the EV example, which is maybe tied in obviously to energy, but I think it's trying to meet that customer when they have a pain point or a change in their behavior. Maybe they're going from a smaller house to a bigger house. Maybe they've switched out some other piece of equipment. So again, I think it's meeting them at those touch points where, oh, this impacts my energy use. And I think, we touched on some of those digital ones. I just think that digital, touch point is important. And I don't know that a lot of utilities have done that. I think, again, it's trying to think beyond. I mean, some utilities have thought about trying to go beyond energy provision and whatnot, but I think that steps into other areas, whether that's services and whatnot. And I think that could be an area where the utility helps, but when you step into other areas that are outside the domain, I'm thinking of maybe cellular service or even, that kind of broadband service. And I've seen utilities try that, and in some cases it can work, but I think going outside that normal realm of energy management can be a challenge. I don't know if that answered your question, though.
It does. It was an intentionally abstract one, I guess.
Okay.
So one other question here for you, Neil, and Mike, feel free to weigh in as well. Observation that Bidgely has made over the course of the past 2 years or so is increasing level of investment from utilities in marketing automation solutions, and the infrastructure, if you will, to communicate with customers in a variety of different ways. I think there's this open question as to how well those types of communication solutions are tied into the AI and machine learning applications that both of you have talked about today. So curious about general observations and whether or not investments in things like Salesforce Marketing Cloud, for example, factored into any of your research, and what your thoughts are on that part of the evolution of the utility customer relationship.
Yeah, I'll take that. I still think, broadly speaking, that it's fairly early days for most utilities if they've even stepped into that realm. But I think, as the practices become more common and, the mistakes and the learnings are made, I think more utilities will do that. And again, I tend to recommend or hear from both utilities and vendors that trying to do it all at once is probably a really bad idea. So pick your choice of either channel or method, whether that's, going from paper reports, let's say, and home energy reports to text messaging or email. That's fairly simple, but then taking the next step, maybe you think about video, you think about some other ways of meeting customer needs. And I also think there's partnerships out there. It could be at the retail level, like a digital marketplace. And again, tying those things together step by step makes sense. So again, I think it's still fairly early days, and I think it makes sense for utilities to bite off what they can do over the next X amount of time and not do it all at once. It's a learning process.
Great. I don't have any other questions for you. So yeah, I really appreciate it. Thank you both again for your time. It was a very interesting panel, even though we're kind of piecing it together in an odd way. So appreciate your flexibility.
Thanks, Colin. Thanks, everyone.
Thanks.
Take care.
Bye-bye.